Dear students, today I give lectures in this lockdown period. I hope you are all well about pressure and force, chapter 11 of your class 8. Chapter 11, force and pressure. Force. At first we write its definition and what will be the questions in this relation. Later we give it. Force is defined. Force is defined as a push or pull, which changes, or tends to change, That is, force is defined as a push or pull which changes or tends to change the state of rest or of uniform motion along a straight line, along a straight line or changes the direction of motion, changes the direction of motion or changes the shape and size of an object, changes the shape and size of an object. Clear? Force is defined as a push or pull. It is either push or pull which changes or tends to change, maybe change or try to change, changes or tends to change the state of rest or of uniform motion along a straight line of a body, obviously of a body, or changes the direction of motion or changes the shape and size of an object, that is of an object or of a body. This is the definition of force. Now we know various units used for measuring force. Units of force in the various systems of unit, and we define them separately. Units of what unit is taken here? Absolute units. Absolute units. Absolute means it does not depend upon the place of measurement. Absolute units of force in various systems. In CGS system, that is centimeter gram second system, in CGS system, the unit of force, the absolute unit of force, the absolute unit of force, the absolute unit of force is dyne. In CGS system, the absolute unit of force is dyne. In FPS, that means foot pound second system, that is the unit of force. It is poundal. It is poundal, and this is very important in MKS or SI system. The absolute unit of force, absolute unit of force is Newton. It is symbolized by capital N. It is denoted by capital N. Hence, absolute unit of force in various systems. In CGS system, the absolute unit of force is dyne. In FPS system, that is the unit of force is poundal, and in MKS system, it is Newton. And which is denoted by capital N always. Now, we define that. At first, we define the dyne, and then poundal, and ultimately Newton. Newton is very important. Dyne is obviously the absolute system. It is the unit of force. Dyne is defined as that amount of force which when acting on a body of mass 1 gram, write it 1 gram, producing in it an acceleration of 1 centimeter per second square. Dyne is defined as that amount of force which when acting on a body of mass 1 gram produces in it an acceleration of 1 centimeter per second square. Now, what do we mean by pounder? The in FPS system, the absolute unit of force is pounder. We omitted the time term here. Poundal, we write poundal is defined as that amount of force which, when acting on a body of mass 1 gram, not mass 1 pound. Here 1 pound. It is written as 1 pound. 1 lb. lb is the pound, symbol of pound. lb. Producing in it an acceleration of 1 foot per second square. This is foot, ft. 1 foot per second square. Hence, poundal is defined as that amount of force which, when acting on a body of mass 1 pound, producing in it an acceleration of 1 foot per second square. This is the definition of poundal. Now, we define the SI unit of force, that is Newton. We write it Newton is defined as that amount of force which, when acting on a body of mass 1 kilogram, right? 1 kilogram, producing in it an acceleration of 1 meter per second square. 1 meter per second square. This is the definition of Newton. It is the absolute unit of force in SI system. Now, we know the questions, related questions. Define, but write down, define number 1, A. Define the term force, which is already defined, that is, we give the definition of force. Define the term force. Or write down what do you mean by force, or what do you mean by force. What do you mean by the term force? By force. Number B. Write the absolute SI unit of force. Write or give, obviously. Write the absolute SI unit of force, or define Newton. We already discussed earlier. Define the term force, or what do we mean by the term force. Write the absolute SI unit of force, or define Newton. Similar answer. This question will be as following, that is, write the absolute in different systems. Write the absolute unit of force in CGS system or FPS system, but it is important, hence it is given here in the question form. Now, if a force is applied on a body in any direction, then the direction of the body is by which the force after the application of the force is called direction of the applied force. Direction of the applied force. Write in your exercise book. The force is the cause of motion. That is, force is the cause and the motion of a body is its effect. Motion of a body is its effect. Force is the cause and the motion of a body is its effect. Right? Now, different types of forces. Different types of forces. We give it as a table. We show it as a table or chart. Table. Now, at first we take the turn force. The turn force. Force. Now, force is divided into two parts. Here, write it separately. Two parts. One is contact forces. Contact force. Contact forces. Number two, here, distant forces or the non-contact forces. Distance forces. That is action of force from distant. Right. Distant forces. Distant forces. Action at a distance. Distant forces or non-contact or non-contact forces. Now, contact forces are of two types. Contact forces are those forces which, when acting on a body, the contact must be required. Contact must be required between them. That is, they are not separated. Contact forces are example of muscular force. Muscular forces. Muscular force and here frictional force. Frictional force. Muscular force and frictional force. We write it in a separate way. In a separate way. In a separate way. Muscular forces. M-U-S-C-U-L-A-R. Muscular. Muscular forces, frictional forces. Distant forces, that is force acting at a distance, not actual contact. Not actual in contact. Or touch. Not touching to each other. Next. Distant forces are gravitational forces, magnetic forces and electrostatic forces. Magnetic forces, electrostatic forces, gravitational forces. Remember it. Right. When we write only force, then S to be omitted. Distant forces. Distant or act at a distance. Muscular force, frictional force, distant forces or non-contact forces. Non-contact force are of three types here. Number 1, gravitational force. Gravitational force. Number 2, electrostatic force and magnetic force. Electrostatic force. And number 3, magnetic force. Magnetic force. We discuss in this case different types of force. Which are the different types of force? Contact force and distant forces or non-contact forces. Contact forces and distant or non-contact forces, distant forces. Contact forces are of two types, muscular force and frictional force. Distant forces are of three types here: gravitational force, electrostatic force and magnetic force. Now we know something about these types of forces. Now right, we just define them without any written in the board. Muscular forces are those forces which, acting by a muscle with direct contact on another body. For example, human being has muscle and they act force on another body. For example, if we lift a book, if we lift this duster, then muscular force is acting on this body. Muscle gives force. In the case of frictional forces, we define it in the chapter, in this chapter classes of friction. Frictional forces are acting between two bodies in actual contact, and it acts when the two bodies are in relative motion. Then against the relative motion, the frictional force, the force acting on a body, is called frictional force, and this force acts along the between the surface of separation, along the tangent in it, on the surface. We have frictional forces in another chapter. Gravitational forces, the forces acting on a body by the attraction of the earth, that is by exerting a force by earth towards its center. This is called gravitational force. It is a special case of gravitational force. It is called gravity, force of gravity, or simply gravity. Now, electrostatic force are the forces acting between two charged particle or one charged particle and another uncharged conductor. We know that in the case of two charges, like charges repel each other. This is the principle of electrostatics. Like charges repel each other and unlike charges attract each other. Charges are of two types, positive charge and negative charge. When positive charge and positive charge are brought in a smaller distance, then the force of repulsion will act to each other. And if negative charge and negative charge are brought close but not in contact, here contact is not necessary, then also repulsive force acting between the two charges. But if a positive charge and a negative charge, if a positive charge and a negative charge is brought near to each other, but actually not contact is necessary, near each other, then they are attracted to each other, because unlike charges attract each other, like charges repel each other. Now, similarly, magnetic force, that is a magnetic pole or magnet, a magnet of any pole, north pole and south pole always occur in pair. This magnet attracts another magnetic substance, not magnet. is necessary. That is, magnetic substance means iron, cobalt, nickel, alnico alloy, and so on. In the case of two poles, either N pole or S pole, are brought near to each other, then also attraction or repulsion acts. In the case, if two N poles or two S poles are brought near to each other, then repulsive force will act between them. And if two unlike poles, that is N pole and S pole, are brought near to each other, then force of attraction will occur. Or that is, they exert forces of attraction to each other. Now, we know the effects of forces. I discuss it only. The effect of forces are forces may change the state body in motion, that is, stationary body in motion moves a stationary body. Force, one effect is force is moves and stationary body. If a body, for example, this duster on my hand is stationary, but it may be lifted or displaced from its position, then the force must be exerted on it so that it displaces its position is changed. Now, the force, another effect of force, it changes the direction of a moving body. For example, if a car exerted the force by its engine, it may bend in a bend road. Then the force by the engine exerted on the vehicle, that is bus or any other vehicle, then the force changes its direction of motion. The motion is increased or decreased by a force. If the force is exerted on a body in the direction of motion, then speed of the motion will increase, and if the force exerted on a moving body in its opposite direction of motion, then it retards, that is, its speed changes. Similarly, a force can be gives effects of change in shape. It gives change in shape or size of a body. For example, if we take a sponge ball or sponge piece and we press them, then its shape and size both are changed. In the similar case, we use in our daily life toothpaste. If it is squeezed by our hand to emanates to run out the toothpaste from the tube, force must be exerted on it, and in this case the toothpaste shape is changed. Now, we know the question: what are the main types of forces? We have already mentioned, that is contact forces and non-contact forces. Contact forces are muscular forces, frictional forces. Non-contact forces are electrostatic forces, gravitational forces, and magnetic forces.